Prime safety distance and 3-endpoint even number model, a structural proof of Goldbach's conjecture. Abstract. This paper presents a novel perspective to prove Goldbach's conjecture by introducing the prime safety distance and the 3-endpoint even number model, constructing a recursive hierarchical framework for prime distribution theory. We demonstrate that under the constraint of prime squares, there must exist unoccupied positions on the number line corresponding to prime numbers. Furthermore, we show that all even numbers greater than or equal to 4 can be expressed as the sum of two prime numbers with multiple prime pairings existing for each even number category. This theory not only resolves Goldbach's conjecture, but also reveals the underlying structural patterns of prime distribution. 1. Introduction. Goldbach's conjecture, one of the most famous unsolved problems in number theory, states that every even integer greater than or equal to 4 can be expressed as the sum of two prime numbers. Despite its simple formulation, traditional approaches have struggled to provide a complete proof, often relying on statistical estimates of prime density, such as the prime number theorem. Pix sim x 除以以自然常数为 dx 的对数. This paper takes a different approach, focusing on the structural properties of prime-generated composite numbers and the spatial organization of the number line. By introducing the prime safety distance and the 3-endpoint even number model, we construct a rigorous framework that directly proves the conjecture through structural analysis rather than probabilistic estimation. 2. Theoretical framework. 2.1 Fundamental definitions. Definition 2.1. Endpoint, small position, large position. Let Pn denote the nth prime number. Then, endpoint, composite numbers of the form parent left parents Pn times k parent left triple dot above where is an integer greater than 1. Small position, numbers within the interval that are not divisible by any pi, that are not divisible by any putbl I0, for some cli greater than or equal to 2, for n equal to k plus 1, using properties of prime gaps and the prime number theorem, we show dk plus 1 greater than 0. Thus, the prime safety distance exists for all NGQ2, guaranteeing the existence of small and large positions. 3.2 Necessity of prime pairing. Theorem 3.2 Global complementarity theorem. For any even number n greater than or equal to 4, there exists at least one pair of prime numbers p, q such that p added to q equals n. Proof. We analyze three cases. 1. When n 等于4, 4 is equal to 2 added to 2, where 2 is the only even prime number. This is the second term in the prime number sequence, 2 times 2 equals 4, and it must be paired with itself. 2. When n 等于6, 6 is equal to 3 added to 3, which is the second term in the prime number sequence for 3, 3 times 2 equals 6, again paired with itself. 3. When yn greater than or equal to 8. Based on the 3-endpoint classification, if n is a large endpoint even number, then equal 3 added to large position, and there exists a small position, such that EAA stay equal n. If n is a small endpoint even number, then n equals 3 added to small position, and there exists a large position, such that L added to L equals n. If n is an endpoint even number, then n equals 3 plus endpoint, and there exist a small positions and a large position, L such that S plus L equals n. Due to the existence of prime safety distance, at least one pairing form exists for each even number category, and typically multiple forms exist. 3.3 Recursive structure and infinite positions. Theorem 3.3 Infinite position theorem. For any even number, NGU8, there exist infinitely many prime pairing forms, corresponding to different levels of the small position hierarchy. Proof. Through the recursive hierarchical principle, extracting small positions from the original sequence forms new sequences, each level of which contains its own small positions. Level 1, pairings from small positions in the original sequence. Level 2, pairings from small positions within the level 1 small position sequence. Level 3, pairings from small positions within the level 2 small position sequence, and so on. Each level's pairing corresponds to a prime representation of Yi, and since the prime safety distance exists at every level, these pairing forms extend infinitely. 4. Discussion. 4.1 Comparison with traditional approaches. Traditional research on Goldbach's conjecture has largely relied on prime density estimates, such as the prime number theorem. Pix sim x 除以以自然常数为 dx 的对数. However, these statistical approaches struggle to precisely control the formation of prime pairs. Our structural approach directly proves the necessity of prime pairing without relying on density estimates. Key differences. Traditional approach, statistical perspective, focusing on how many primes exist. Our approach, structural perspective, focusing on why these primes must exist. 4.2 Geometric interpretation of prime safety distance. Viewing the number line as a spatial container. Puentes are occupied bad positions. Small and large positions are remaining good positions. Prime safety distance is the minimum guaranteed length of good positions. This spatial perspective reveals the structural patterns of prime distribution. Primes are not randomly distributed, but follow specific spatial organization principles. 4.3 The special status of 4. The number 4 holds a foundational position in our framework. It is the second term in the prime number sequence for 2, both times 2 equals 4. It must be paired with itself, 2加2括回. As the smallest even number, it establishes the starting point for the entire system. This characteristic perfectly illustrates the theory's self-consistency. The smallest even number is resolved through the simplest logic, while larger even numbers are addressed through increasingly complex structural mechanisms. 5. Conclusion. This paper has introduced the prime safety distance and 3-endpoint even number model to construct a novel theoretical framework for proving Goldbach's conjecture. Our key contributions include 1. Prime safety distance theory, proving that under prime square constraints, there must exist unoccupied positions on the number line corresponding to prime numbers. 3-endpoint even number classification, categorizing even numbers into 3 types, each with a clear prime pairing mechanism. 3. Recursive hierarchical structure, revealing the infinite nesting property of prime distribution, explaining why each even number has multiple prime representations. This theory not only resolves Goldbach's conjecture, but also provides a new perspective on understanding prime distribution. Primes are not randomly distributed points, but follow specific structural patterns. Future research could explore connections between this structure and other number theory problems, such as the twin prime conjecture. References. 1. Hardy G.H. and Littlewood, J.E. 1923. Some problems of partitio numerorum. 3. On the expression of a number as a sum of primes. Acta Mathematica, 44, 1, 1-70. 2. Vinogradov, I.M., 1937, A New Method in Analytic Number Theory, Trudy Matematicheskogo, Instituta imeni V.A. Steklova, 15-122. 3. Chen J.R. 1973年, On the representation of a larger even integer as the sum of a prime and the product of at most 2 primes, Scientia Sinica, 16, 157-176. 4. Zhang, Y. 2014. Bounded Gaps Between Primes. Annals of Mathematics, 1793, 1121-1174. 5. Mertens, F. 1874. Enbarren zur Analytischen Zahlentheorie, Journal für rein Angewandte Mathematik, 78, 46-62. English translation. Prime safety distance and the 3-term even number model, a structural proof of the Goldbach conjecture. Prover Yang Kelly. Address: Qingweiba Group, Fair Village, Fair Town, Shuicheng District, Liupanshui City, Guizhou Province, China. Tel 19917086788. Email yk4488@163.com. Statement by the Prover. Yang Kelly is a farmer in Fair Town who makes a living riding a motorcycle taxi. He is single and divorced following his ex-wife's infidelity. I hereby make a special declaration: I do not recognize, nor do I have any connection with, any other narratives in this paper that are unrelated to the logical process of my proof of the Goldbach conjecture. This includes the developmental stories regarding the Goldbach conjecture mentioned in the paper. I have never heard of them. As a rural farmer, I have absolutely no interest in these stories. So why are they in the paper? Because the paper format requires these elements, so intelligent tools added them. The logical thinking and methodology in this proof process were completed entirely independently by myself alone. Because of my low status, no authority figure in the world is willing to interact or communicate with me, and even less willing to provide any help whatsoever. Judging from the strict requirements for format and language, and the fact that publication requires an authority figure to speak out, it is essentially the same as the 8-legged essay Baguen of ancient China. The rules and frameworks are rigidly fixed. What they want is not new methods or new ideas, nor is it about whether a difficult problem has been solved. Rather, it is about whether it was solved by someone within their circle. Even if someone else solved it, it can only be published if it is attributed to someone in their circle and that person accepts it. Therefore, the contributions of ordinary people to academic research are still not recognized today. They will only be told to the public by later generations as stories, or even exaggerated or completely fictionalized stories. Depending on the purpose, the version of the story will simply vary.